Last subject of the day, science. So did you tell me what you thought about the video that you watched? Biscuit's telling me. Hi, baby. What did you think about the video of her trying to do all 5 of those? The very last one, the inertia where the eggs actually made it into the container of water, that was impressive. I'm not gonna try that. That looks like an absolute mess waiting to happen. However, remember that you'll pick just one and then you will recreate it. But I don't want you just to do it. I want you to explain it. I want you to tell us the ingredients and how you go about it. And then I want you to tell me why, first, what is happening, and 2, why it's happening. That's where we get to learn, okay? All right, we are in science. We are on page 109, and it is section 5.4, when water changes its state, okay? I'll read and then I'll tell you what to highlight and we'll go from there. Water's melting point. Molecules of solids are packed together, tightly together, and they move slowly. In most solids, the molecules have a strong attraction for each other. This means that they will stay close to each other and hold on. When solids are heated, the molecules begin to move more rapidly. All right, so let's think about this. First, you have solid. All right, they're packed tightly together and they move very slow. So highlight that very first sentence. Then go down to, it says, when solids are heated, the molecules begin to move more rapidly. So we're going to highlight that. If they move fast enough, the attraction between molecules is not strong enough to hold them together as a solid. The solid can melt and become a liquid. The molecules have not changed, but their motion has overcome the attraction that holds them together. So the motion, because of the heat that's applied, they're moving. They're not necessarily together as a solid. They're still the same molecules, but now they're liquid. Yeah, that makes sense, Ms. Taylor. All right, highlight that. In fact, it starts with the solid can melt and become a liquid. And the next one, the molecules have not changed, but their motion has overcome their attraction, and that holds them together, and thus they go from a solid to a liquid. Not all solids melt, and solids that do melt do not all melt in the same temperature. The ice cube in Karen's glass melted at room temperature, but the glass itself didn't melt. It was solid, right? The temperature at which a solid changes to a liquid is called its melting point. Highlight that. We know that the melting point of water is 30 degrees Fahrenheit. So those last 2 sentences, I want you to highlight that. Now, that was melting point. Let's talk about boiling point. Just as heat can cause a solid to turn into a liquid, so heat can cause a liquid to change into a gas. Increased heat causes the molecules to move even faster. And finally, the attraction between the molecules is not enough to hold them together as a liquid. So they went from a solid to a liquid, and now it's even hotter, and now they're going to go to what? Change into the state of gas. The molecules break apart, and the liquid becomes a gas. The temperature at which a liquid changes to a gas is the boiling point. We know that the boiling point of water is 212 degrees Fahrenheit. You'll need to highlight all of that. Start with the molecules break apart, and then the liquid then becomes a gas. All right, we know that this is called the boiling point, and it's 212 degrees Fahrenheit. Liquids also become gases through the process of evaporation, but we'll discuss evaporation later. Unique water. There's something very specific about and unique about water. Because of the way its molecules are made, water does not behave as other liquids do when it changes state. Most substances expand or get bigger when they are heated, and then they contract when they get smaller. This is true of solids, liquids, and gases. It is true of water at most temperatures. However, the temperature at which liquid water changes to a solid, 32 degrees Fahrenheit, is called the freezing point. Did you notice that water's freezing point and melting point are the same? When water is at 32 degrees, some of its molecules are solid and some of them are liquid. Just before water gets cold enough to freeze, a strange thing happens. At 39 degrees Fahrenheit, water begins to expand, which means it gets bigger, and become less dense as it gets colder. Water that is colder than 32 degrees Fahrenheit has completely changed to solid ice. Ice is larger and less dense than the same amount of liquid water. This is what causes ice to float. If water behaved as other liquids do, ice would then become smaller and denser, like compact, right? Well, what would happen then? Yes, that ice would sink, wouldn't it? All right. Question is, why does only water do this? It says scientists have not discovered exactly why, but if you think for a minute, you can see that it's an awfully good plan. Think of a very cold winter day. The water on top of a pond will freeze. If the water acted like other liquids, the ice would contract, get smaller and denser, heavier, and then it would sink to the bottom. More and more ice would form and then sink to the bottom. Soon the pond would be a solid ice. What would become of the fish and the plants that are in that pond? What would happen if the same thing happened in lakes and rivers and oceans? So when water freezes, it expands, it's less dense, and it floats. It doesn't freeze and contract and then sink. Instead of contracting and sinking, ice expands and floats. Ice on top of a pond or a lake helps protect the water plants and the fish during very cold weather. They live securely beneath the ice until it melts in warmer weather. Because water expands when it reaches the freezing point, water life continues. Can you see that this is a good plan? Who you figure thought of that plan? Do you think that happened by accident, or that God knew that we needed water and that we needed this wonderful cycle that He has created for us? Yes. So I need you to complete Comprehension Check 5.4. It's on page 110. I will send the answers to your parents later so that you can check 5.1, 5.2, 5.3, and 5.4 to make sure you've correctly answered all those answers, okay?